Welcome back to 7th Science. Today we're going to be doing the LearnEd Notebook section of forces of motion called Newton's 3 laws. Now most of you might think, oh, I know Sir Isaac Newton, he had an apple fall on his head. That's actually not exactly what happened. So Newton was a scientist, he went to university, and he spent a long time studying the laws of how, or the rules of how the world worked, and asked questions. And it was his curiosity and inquiry into the world around him that really set him apart as a scientist and allowed him to get some insights into how the world works and how things interact with each other to cause the world to work the way it does. Newton is most famous for his 3 laws of motion. The first law is called the law of inertia, and we can phrase it as objects in motion stay in motion, and objects at rest stay at rest unless acted on by an unbalanced force. The second law of motion that Newton has is pretty simple. It can be put out as an equation here. Force equals mass times acceleration. And most people just write that as F equals ma. That is a way to talk about his second law. And his third law that he states is that for every action, there's an equal and opposite reaction. So let's talk about law 1. Law 1 is for objects in motion stay in motion, and objects at rest stay at rest unless acted on by an outside force. Now, this ball is in motion right now if I throw it up. And as the ball goes up, its motion is going in the upward direction, and according to that law, the only thing that would cause it to stop from going up forever is an outside force. Now, what outside force is causing this ball as I throw it to stop its upward motion? If you thought gravity, then you are right. If you thought also that it was fluid friction, then super smart. Now, objects that are moving straight through the air are going to experience that same gravitational force and fluid friction force acting on them, but instead of pulling them straight down and causing the ball to fall, most likely the object's inertia, which is again Newton's first law, will keep the ball moving at an angle, which is why if you throw a ball sideways, it doesn't just fall straight down. There's some sort of angle happening there as the forces start to interact, gravity with fluid friction and the momentum of the ball. So Newton's first law, or the law of inertia, explains what keeps objects staying in their state of motion. Inertia essentially is a force that resists a change in motion. Now, the more mass an object has, the more inertia it has, or the harder it is for an object to change its state of motion. A heavier object is harder to move or change from its state of motion than an object that is lighter or has less mass to it. You can see this at work in the tablecloth trick. Maybe you've tried this at home or seen it, but the idea is that if you pull on a tablecloth really quickly and smoothly, then you can potentially pull the whole tablecloth out from underneath a place setting, or in this case, a bottle or a vase, without knocking anything over. So because both objects on the table have mass, and the greater an object's mass, the more inertia it has. And inertia is essentially the property or the force that keeps objects with mass from changing their state of motion. So that's why it's harder to move a bowling ball versus a pencil. Heavier objects in a table tend to work better, but objects with inertia, with enough inertia, should be able to remain on the table without being knocked over by the tablecloth being pulled away quickly enough. So the next law that I want to look at is Newton's second law. Force equals mass times acceleration. Now, force, we already know, is a push or a pull on an object. Mass is the amount of matter that something has. So I could say that this probably has less mass than this because they're roughly similar in size, but this has more matter to it. So we would say that this has more mass. Therefore, if I threw both of these at the same acceleration, using the formula F equals ma, the one that has the greater mass would have a greater force. Most of you already know this intuitively, though. If I was to say what would hurt more if you got hit with a snowball or a baseball, you would think probably the baseball because it has more mass. What is harder to throw, a baseball or a bowling ball? Now, both of those have rolling friction acting on them, but they have different masses. So because they have different masses, if you threw them at the same acceleration, the same speed, it would have a much different force, the baseball versus the bowling ball. And that's essentially how Newton's second law works. If you want to figure out the force on an object, you can find the force by measuring how fast it's accelerating towards something and how much mass is it. So how fast is it going and how much matter does it have? That will determine how much force an object has in its motion. Newton's third law, every action there is an equal and opposite reaction, is a little bit trickier for some people to grasp, but hopefully we'll get into it and understand it by the end of this video. Now let's look at this ball on my hand here as an example here. So I have a ball sitting on my hand, which means there is an action. The action is that gravity is acting down on this ball and pushing it into the palm of my hand. That is something that we can call an action. Now, there must be, according to Newton's third law, an equal and opposite reaction, which means that if the action is pushing down, the ball's pushing on my hand, then the reaction, which is equal and opposite, is the hand is pushing up on the ball. Now, that doesn't mean that every action and reaction has the same amount of force, because if that happened, then everything would be locked and frozen in time because nothing would be able to move. If you remember what we talked about in forces, if everything had a balanced force on it, then eventually nothing would move or change its motion because all forces would be equal, which means if I pushed really hard on this ball to try to move it this way, it would resist with exactly the same amount and it would never move. Now, what happens in Newton's third law is it's just showing you that there can be an equal and opposite reaction to a point, but eventually if you have more force, like my hand has more mass, if I push on something that has less mass, then odds are it's going to move. So equal and opposite reaction means that if I push left on the ball is going to react and push right against my hand. And I can keep adding force until eventually the ball won't be able to resist my motion or pushing it left and it will move left. So with that, we're going to use a Nearpod to fill in the blanks for info in the Learn Ed Notebook section for Newton's 3 laws. There's some diagrams there to look at, but essentially we're going to be looking at the law of inertia, which is law 1. We'll look at what the law of force, mass and acceleration, which is law 2, and action-reaction is law. I hope this video makes sense. If you have any questions, you can always send me an email or see me in Zoom or put a comment on the video in YouTube, and I'll try to get back to you as soon as I can.